Okay, the whole idea behind linear programming is to find an optimal solution given a set of constraints or criteria. For example, wanting to maximize profit while at the same time minimizing cost. So what we do is we take all these constraints, which are going to be in the form of a linear inequality. We take all these constraints, we sketch and graph them, establish what is called a feasible region. So that'll be the intersection or the boundary, the region that is bound by these constraints, by these inequalities. Once we've established that feasible region, we can then interpret the problem. So these constraints, these linear inequalities, help us optimize a function. So we'll take, for example, a profit line. We want to maximize profit. So we'll, for example, sell cardboard boxes, large ones and small ones. And we want to be able to maximize profit while at the same time keeping the cost down. Obviously, to manufacture a large cardboard box would cost more than manufacturing a smaller cardboard box. So you take all these constraints into consideration. We sketch these constraints, these linear inequalities, and the intersection of those constraints form a feasible region. And from that feasible region, we can then interpret and determine the solution, the optimal solution to all of these constraints. So that's the whole idea behind linear programming. Once we've sketched all the constraints, all the linear inequalities, we interpret each inequality and shade regions on the graph that represent these inequalities. The inequality greater than and greater than or equal to implies that we shade above the line drawn and to the right of the line. The inequality less than and less than or equal to implies that we shade below the line drawn and to the left of the line. The inequalities greater than and less than imply that the sketched line is dotted or exclusive, and the inequalities greater than or equal to and less than or equal to imply that the sketched line is solid or inclusive. This will all make a lot of sense as we work through some examples. So the first example, to sketch the linear inequality y is greater than or equal to 2, we are first going to sketch the straight line y equals 2, which is just a horizontal line on your Cartesian plane that passes through the point where y equals 2. So that's indicated by the black solid line on the grid. The inequality is greater than or equal to. It's y is greater than or equal to. All inequalities have to relate to y, the variable y. So because the inequality sign is, if you look at it as a mouth, a crocodile mouth, it is pointed towards the variable y. That means that y is greater than, in this case, greater than or equal to. So the inequality greater than or equal to implies that we shade above the line y equals 2. So we just take our pen and we just gently mark shading above the line. What this shading implies is that y values above this line, y equals 2, this is the line y equals 2, all y values above this line are greater than 2. That's all the inequality means. So we just shade above the line accordingly. And we could just indicate that by shading in the region above that line, y equals 2. To represent the constraint or linear inequality, x is less than 3, we first sketch on the Cartesian plane in the first quadrant the straight line x equals 3. The exclusivity of the inequality, so what I'm referring to, the exclusivity is the lack of that equal sign underneath the inequality, okay? What I've just drawn there is the inclusivity, which means x is less than or equal to 3. But in the absence of that line underneath the inequality indicates exclusivity. That means that x can be any value less than 3. Not equal to 3, less than 3. Any real value less than 3. So the fact that we have this exclusivity implies that the straight line we sketched, x equals 3, must be dashed or dotted. That dotted line indicates exclusivity, which means x cannot be that particular value. And the inequality is less than, so relative to the variable x, the mouth of the inequality is pointing away from x. That indicates x is less than, and that inequality less than implies that we shade to the left of the line. So we take our pen and we just shade to the left of the line, and you can color that in as it's indicated over here. To sketch the inequality, y is greater than or equal to x plus 1. We sketch the straight line y equals x plus 1, so we're going to use the dual intercept method here. It's just easier to use the dual intercept method. You find the x-intercept for that straight line and the y-intercept, plot the 2 points, and sketch a straight line through them. Once you've sketched the straight line y equals x plus 1, the inclusivity of the inequality, greater than or equal to, implies that the line is solid. In other words, the inclusivity we're referring to is that little line underneath the inequality. If that is present there, it implies inclusivity. That means that the value, the smallest possible value of x plus 1 is included in the solution to the inequality. So this inclusivity, y is greater than or equal to, implies that the line is solid, as indicated. Now, the inequality greater than or equal to, y is greater than or equal to, means that we shade above this solid line, y equals x plus 1. So above the line, we just take our pen and we just make small markings above the line. And then we can take a highlighter and just shade the region as indicated. To represent the inequality or constraint, y is less than x minus 2. We are going to sketch the straight line y equals x minus 2. Again, we use the dual intercept method. We find the x-intercept and the y-intercept, plot those 2 points, draw a straight line through them. Now, the inequality sign is less than. Y is less than x minus 2. So this less than, the lack of the inclusivity. So the inclusivity I'm talking about is the line underneath, that equal line underneath the inequality. That is absent, which means that the line that we sketch has to be dotted and not solid. So we have our dotted line, and the inequality is less than, so y is less than x minus 2. That less than symbol, inequality, means we are shading below the line we have just sketched. So we take our pen and we just indicate little markings below the line. You can take your highlighter and highlight the region enclosed by that constraint. And here we are given a feasible region R that is enclosed by 1, 2, 3 inequalities. They have sketched the line x equals 4, and we can clearly see that this line is dotted. Okay, we know what that will mean because that relates to an inequality being exclusive, an exclusive inequality. We also have this line over here in purple, which is solid, indicating that inequality is inclusive, and that is 10y plus 8x equals 80. Then we have third inequality, which is this one in turquoise, which is dotted, which means that the inequality is exclusive, and the equation of this line is 2y equals x minus 4. So we have sketched 3 straight line graphs, and indicating inequalities from that straight line graph depends on whether the line is solid or dotted. Solid meaning that it's an inclusive inequality, and dotted meaning it's an exclusive inequality. So now we're just going to write down the inequalities that are represented by the purple, turquoise, and green lines. So the feasible region is this white blank region over here. So if we just make our markings, basically R is the enclosure bound by these 3 straight lines. So clearly R lies to the right of the green line. So we're going to indicate that by making markings to the right of that line. R lies above the turquoise line, so we make a marking accordingly above that line. And R lies beneath the purple line, so we're going to make markings accordingly on the diagram. Now we're going to interpret what this all means. So if we take the straight line x equals 4, now R lies to the right of that line. And this line, if we just remove just erase that marking for now. It is a dotted line, which means that the inequality is exclusive. And the fact that the region R lies to the right of that line, that means that x values to the right of a line are greater than, right? Here is the value x equals 4. To the right of 4 are values of x that are greater than 4. To the left of 4 are values of x that are less than 4. So the fact that the region lies to the right of 4 means that this inequality is x is greater than 4. Not equal to, because the line is dotted. If it's dotted, it's exclusive, it's not solid. And if it's not solid, it is exclusive, and then we therefore have inequality greater than 4, because the region lies to the right of 4. So there's our first inequality. Let's take the turquoise inequality now. The region R lies above that line. The equation of this line is 2y equals x minus 4. So the fact that we are shading above that line, the region lies above that line, and the line is also dotted. So the fact that it's not a solid line, therefore it's an exclusive inequality like this one here, and the region R lies above that line. So y is greater than, so 2y is greater than x minus 4. That is the second inequality. The last inequality is the purple shaded, the purple marked straight line. The equation of that line is 10y plus 8x equals 80. Now, the region R lies below this line, and below a line is indicated with an inequality less than or equal to relative to y. So the fact that the region R lies below this line means that the inequality sign will be less than or equal to. But to know which one we're going to be using, we can't use both. We just look at the state of that line, its nature. It is a solid line. That means that our inequality is less than or equal to. So 10y plus 8x is less than or equal to 80. And that is our third inequality.